Half adder is a combinational circuit which adds two 1-bit number. This is the block diagram of half adder. Here you will find that two inputs are named as A and B, and addition of these two bits will result in sum and carry. This is the truth table of half adder. A and B are the inputs. In the first case, 0 is added with 0. So sum will be 0 and there will be no carry, that is carry is also 0. In second case, 0 plus 1 results in sum 1 and carry 0. In third case, 1 plus 0, sum is 1, carry is 0. In the last case, when both A as well as B are 1, then in that case 1 plus 1, sum is 0 and there is a carry. So by using this truth table, we will derive the Boolean expression for outputs, that is a separate Boolean expression for sum and a Boolean expression for carry will be derived. For that we will use K-map. Let us first derive the Boolean expression for sum. Now as number of inputs are A and B, that is two inputs are there, so we will require a K-map with 4 cells. So this is the K-map. A and B whose possible values are 0 and 1, they are taken, and as the equation is to be derived in SOP form, so 0 is considered as A bar, 1 is considered as A. Same is the case with B. When B is 0, it is considered as B bar. When B is equal to 1, it is considered as B. Now let us mainly focus on sum column. When A is 0 and B is 0, sum is 0. So when A is 0 and B is 0, the value of sum is 0. So output is written inside the cell. In the second case, A is 0 and B is 1. A is 0 and B is 1. So here what I have to write? I have to write the value of sum, and value of sum is 1. So 1 is written here. In third case, A is 1, B is 0. A is 1 and B is 0. So what is the output here? Sum is 1. So 1 is written here. And in the last case, when both A as well as B are 1, sum is 0. A is 1, B is 1, so obviously sum is going to be 0. So this is the K-map for sum. Now what do we do in order to minimize the K-map? We form the group of 4 ones or 2 ones, or a single one is taken. Here quad, that is group of 4 1, is not possible. Pair is not possible because diagonal pairing is not allowed. So we have to take these two ones independently. Say, let us take this first one. Look at the left hand side, it corresponds to A bar. Look at the top side, it corresponds to B. So this product term is nothing but A bar into B. So A bar into B is the first product term. Now what about the next one? So it is encircled, and now look at the left hand side, it corresponds to A. Look at the top, that is column, it corresponds to B bar. So product term is A into B bar. So final expression for sum is equal to A bar B plus AB bar, that is sum of product terms. Two product terms are added together, and this expression we are very familiar with. It is nothing but the expression of XOR, that is A XOR B is as good as A bar B plus AB bar. In short, the Boolean expression for sum is A XOR B. Let us also derive the Boolean expression for carry, that is second output. So again, 4 possible combinations are there. The same K-map will be drawn once again, and inside the K-map the values will be entered one by one. When A is 0 and B is 0, carry is 0. So carry is entered here. When A is 0, B is 1, carry is again 0. So A is 0, B is 1, carry is 0. Third case, A is 1, B is 0. A is 1 means this case, B is 0 means this case, so we are going to enter here. So what is the output here? 0. So 0 is entered here. And the last possible combination, A and B both are 1. A is 1 and B is also 1. So this cell will correspond to the output carry 1. So in this way, the K-map is filled with the output values. Now again, no quad is possible, that is no group of 4 is possible. There are no 2 ones which forms the pair, a single one exists. So encircle it and derive the Boolean expression. Look at the left hand side, it corresponds to A. Look at the top, it corresponds to B. So the Boolean expression for carry is AB. Carry is equal to AB. Now what I have to do? I have to realize this in the form of gates. I have to make the circuit. So obviously for sum one XOR gate will be required, and for carry one AND gate will be required. So this is the realization of this Boolean expression, and this is the circuit diagram of half adder. A, B, XOR will give you sum, and where A are and B are ANDed, they will give you carry. Now one more thing I would like to tell you. Suppose you are being asked that realize or construct the circuit diagram for half adder circuit, but use only basic gates. Basic gates are the gates which are AND gate, OR gate and XOR gate. In such case, the XOR gate which was forming the sum will not be allowed. So what we have to do? We have to just take the expression sum is equal to A bar B plus AB bar, and obviously carry is AB. To generate A bar and B bar, I will require two NOR gates, NOT gates. A bar B AND gate will be required. AB bar AND gate will be required. AB AND gate will be required, and this plus correspond to OR gate. And this is the diagram for half adder using only basic gate. So A and B are the inputs. A is connected to NOT gate, so it will give you A bar. This is B. A bar into B, output will be A bar B. In second case, A is directly connected to AND gate, but B is connected through NOT gate, so output of NOT gate will be B bar. This is A, so A into B bar will be the output of second NOT gate. And when these outputs are connected as input to the OR gate, it will give you sum, and sum is nothing but A bar B plus AB bar. What about carry? Carry will require only AND gate. So A is connected as first input of AND gate, B is connected as second input of AND gate, and output of AND gate will give you carry in the form of A dot B. Thank you.